Hello everyone, this is Biplab Datta. Welcome to my YouTube channel. Now we'll be solving valid parenthesis problem from LeetCode problem set. The problem number is 20. Now this is tagged as easy. Let's go through the problem statement and see what it is saying. Given a string S containing just characters, the brackets, the round brackets, and the curly brackets and the square brackets. Determine if the input string is valid. If input string is valid, like an input string is valid, the open brackets must be closed by the same type of brackets. Okay, that means the round bracket, open bracket can only be closed by the round closing bracket. Similarly for the other ones. Now open brackets must be closed in the correct order. Open brackets must be closed in the correct order. Means if for example, let's come here. Now let's say we have an open bracket and then we have a open bracket square bracket and then we have a closed round bracket and followed by a closed uh, square bracket. Now in this case what happens is uh, there this is the order of closing is not correct. Okay, this is invalid. However, you can this string is a valid one. Okay, so the ordering must be, so if there is an open square bracket, then it has to be closed first, then the you can close the outer round brackets. All right, so this is clear and this is also clear. All right, so this can be closed by the corresponding pair, and the curly brackets are these, and then we have a square bracket. Now every closed bracket has a corresponding open bracket of the same time. So this is like similar to 1 and 1. All right. Now let's get back to the problem. Okay, so let's go through the examples. The example is given here is that this is the open round bracket followed by a closed round bracket. So there are no other brackets. So this is a valid string according to the conditions given 1, 2, 3. Now in this case, you have this input. This is given. So you have seen you see that if you have let's make it bigger. Okay, so this is what is given. All right. Now, if you see the string, this is open closed like open round bracket is followed by a closed round bracket. So this is a valid string. So we don't need to check anymore. Now next we'll see if this is open square bracket is followed by a closed square bracket. So this is also valid. Now similarly, this is also valid. So this whole string is valid. Here, if you see, you have a open round bracket followed by a closed square bracket, right? So this is not valid. Okay, a open round bracket can only be closed by a closing round bracket. All right, and every closed bracket like this closed bracket should be should have a open bracket of the same type. All right, so this is not valid. Now next we have uh, a round bracket, then we have square brackets, then we have round bracket, closing round bracket. So this follows the order. So these two form a valid string, so we can get rid of this. Then the outer ones, they also form a valid string. Okay, so the ordering is correct. So this is a valid string. Now, what are the constraints given to you? The constraint is the length of the string, which is the input string, which consists only of parentheses. That is of the order 10 to the power 4, and the minimum can be 1. All right. Now, in the minimum case, 1 or length 1, what happens is there will be a single bracket, so it should always give you like invalid bracket, right? You always have to have a pair. Now let's get back to the problem. Now we can understand how to attack this problem. Like the intuition is you have to let's get rid of these things. Now the intuition is, let's take a example, the small example. So what do you have to do? You have to keep track of the previous bracket. Okay, the current bracket we have, let's say, a pointer, and we have to keep track of the previous bracket. And also, like here, this solves the problem, but you can simply like keep up track of the previous, but this is not the case. We'll have different kinds of brackets, right? So what we'll do is we have, let's say, this is a bracket given. Now this also doesn't cause a problem. Like you can have a memory for previous bracket and the current one, you can match it. But the problem arises when you have a nested bracket. So you have to keep track of the previous element just before the pointer, okay, the I, which we are taking to like to point to the current element while parsing the whole string. And we have also to keep track of the all the open brackets. Okay. So in that case, what data structure comes to your mind? Now we need an extra storage. Like this S is given, S is the input string, so it doesn't count for in the space complexity. So what we have to do is we have to like think of a data structure which can be used to keep track of the open brackets. Okay, and we should be able to whenever we find a valid inner string, we can remove that part. Okay, we can just remove it so that the other open brackets which were present earlier, okay, previously, that can be like solved. Okay, that can be checked for if it is valid or not. So what we can do is we can consider a array data structure. Okay, let's say this is the data structure we have. Now what we can do is we can say that, okay, the index, let's say the pointer, let's say j, is at -1. So we keep pushing the open brackets into this. Okay, we keep pushing. So we'll first increment j. So this is, let's say the numbers are 1, 0, 1, 2, 3, 4. Now in this case, what we have is we increment the j to 0. So this is j here. Okay, so we do plus j plus plus. Now this is here. So while we are like, let's take an example and understand. Okay, let's clear this up. We'll come to the data structure which is like used generally for this, like the stack data structure. But let's understand how we can do it using array. You can also see you can also implement a stack data structure using array. So in this case, what is happening is this is the array, let's say. So we can take the array length to be maximum to be of equal to the length of the string, input string given. So let's take an example of the most general case example here, that is the fourth example. So we have 0, 1, 2, 3. Okay, so we are parsing using the I pointer, and we have we have an extra array here, okay, which we'll use to keep track of the open brackets. 0, 1, 2, 3, 4. Now we don't require this much, so let's get rid of this. So the length of the total string is, so the array maximum size we require is this. Okay, in case all the brackets are open. So we have to push all of them. Now, in this case, what we can do is like while we see, like there's the open bracket. So where open bracket, we can keep track of it. So we'll save it here. We'll put j here. Okay. So we increment j and we put the open bracket. Okay. Right? Now next, what we have is this thing that there's a square bracket. This is also open bracket. So let's get I over here. Okay, we are looping through the input string. Now this is also open bracket. We'll push it in. All right, and then we see that when we reach over here, when I is here, we encounter a closed bracket. Okay, so closed bracket means we have to check whether the previous open bracket matches this type. Okay, so if you see this, so we have j over here. Okay, I forgot to write the j over here. Now J is the top of like we'll come to this. We'll make a like comparison between this solution and the stack solution. It's exactly same, just that we are using a array data structure, which every beginner understand, right? So what we have is this is the last bracket we encountered, the open close square bracket. So here we have we in the string, this is the input string. Okay, so here we find that we have a closing square bracket. So this matches, right? So we can close them and we don't require to revisit them. So in this case, we don't push the closing bracket. What we do is instead we just decrement the j. We bring the j over here again. So we do not overwrite, do anything, just that after we increment j again, we'll, of course, if we have, there is a like open bracket available, we can simply replace this. So we don't care about whether the array is empty, the cell is empty or not, just that we have to just keep track of the this j pointer. So this is, you can of course set it to blank, okay, but it's not required. All right. Next, this is now we'll come to I comes here. So when I comes here, you see that if this matches with the type, so we have a like closing round bracket and we have a like open round bracket. So this matches the type, right? So we can simply just like decrement j again, and j becomes -1. So you can see that we can like when we know that the string was valid string. So in this case, what happens is we can see that the array is like it's empty, right? It's not like we cannot say it's empty because we can see the two elements there, but we are referencing this value. So if j becomes -1, that means it was the initial thing where the array was empty. So we can say that if this array becomes empty, that means this should give you a true output as true. All right. Now, if any of these fails, like in the while checking, like if let's say we take example of this thing, the third example. So in that case, what happens is, so we'll take a simple example. So this is example 3. So this is s equal to s is s equal to, this is given to be so we have this string, right? So this is a very simple string. We can of course see and understand like what is wrong with this, but for the computer to see it, we have since the memory locations are in 2D, right? It's two-dimensional, and each memory location is accessed one by one. So but for us humans, we can see in 3D, right? We don't need to do that. We can just directly see and tell that it's not like valid, right? So this is an invalid string, so output should be false. Let's try whatever we have done so far. So we will take the maximum size of the array to be 2. Okay, so this is the array we have, and the pointer we initialize at -1, j equal to -1. Now this is the array of characters. All right. Now in this case, what happens is, let's say this is a string given, input string. Now this this is 0, this is 1. So I will start from here. Now I is here. So this is the open bracket. We'll like push it. Okay, push it means like we'll increment j and make that cell to be that bracket. Now next we move the I pointer. Okay. Now in this case, what happens is you check whether this square bracket, the closing square bracket. Now this is a closing square bracket, right? So we'll check whether this has a matching type on the like the jth pointer location. So we see that no, it doesn't match. All right. So immediately we'll return false. we don't need to check, like even it's a bigger string, if there is a mismatch in the type of closing bracket and this thing, open bracket, all right, which is at j location, we'll simply return false. So output is false over here. So what all things we like did here? Let's like compile it. So the first thing is, whenever we encounter a open bracket, so open bracket of any type, we push uh, we push into array. All right. Now next, if it's not an open bracket, so let's say it's a closing bracket. Now closing bracket could be, the situation could be that all the like it could be that came in the very first in like character, very first, like, or maybe in somewhere between where you have already balanced string, like the valid string, but then is followed by a closing bracket. In that time, what will happen is you'll see that the array is empty. If array is empty, that means j is equal to now the array won't be empty, but this is the indicator, right? And this is where we start. So j minus 1, then that means in that case, what will happen is you can simply say that this is not possible, so return false. Okay, right? Now next case, what happens is if the array is not empty, array has some open brackets, because we are only pushing the open bracket, there won't be a closing bracket inside the array. So array is non-empty. So what we'll do is, now we'll check whether the, so here we have another two conditions coming up, because see, we'll check whether there's a matching type of the closing bracket, matching type of closing bracket. So in that case, what happens is we say that we just simply decrement j, right? Because we don't need that string anymore, because that pair becomes a valid string. So we don't need it. So we just make the j move backward. Or let's say there's it's not matching type, doesn't match. Okay, means jth position has, let's say we have at jth position, say this bracket, and then ith position we have, let's say, this bracket. So this doesn't match, right? So in that case, we'll just return false, right? So these are the cases. And what happens if we are like, we do not fall into this, and let's say like all these options are not, like there's no false return statement, but still there could be a false statement if there is a remaining open brackets in, there are some open brackets, so there will be 2 points. So array could still have, so let me erase this part. What is happening? So array could still have open brackets, means basically we are talking about j is not equal to -1, on b that j is equal to -1. So if j is equal to -1, then the whole string is balanced. Okay, we don't need to check anything else. So that means the array which we are using to store the closing open brackets, they have all matched their corresponding pairs, opening closing pairs. So we can simply do this thing, that return true. And in this case, we can return false, because there are still like, let me write clearly. deleting is a very challenging thing over here. So here, what we have is we'll return false because there are unbalanced opens. So these are the conditions we have to check. Now I hope this is clear. We have to just implement whatever I wrote here. This is the algorithm basically. All right. So let's write it down. Now we'll initiate a character array of length, the same length as this thing. So new character array as length. Now so we'll go character by character. We'll convert the string into a character array, and let's say have our pointer j. So here we are not using the I pointer. We are simply using the character directly. So let's initialize j to -1, which means the array which you're using is empty. Okay. Now, if the character matches any of the open brackets, let's say these are the brackets, or square brackets. Okay. Now, what we do is simply we increment j, and we have j. So we can combine these two steps. Okay. So what we can do is simply increment j, all right, and like put the value there equal to c. Now, if there's a closing bracket, so in that case, we'll check whether this is equal to the array which we are pushing the characters to is empty, means j is at -1. So in that case, we simply return false because we do not have any open brackets which can be balanced with this closing bracket. That is fine. Now, the point is, if we have, let's say, the top of the array means where the j is pointing. So that is given, like we can get the j. Now, now this condition is longer, you have to write a lot of lines here. So c is equal to. Now, in this case, you have to like do it like this, that the c is this character and the top is the matching pair. So you have to like copy this and paste 3 times, or you can type it also if you're fast at typing. So we have to check or for all the three. All right, we'll put a or between them. So this could be this, that, or like any of the three. So we have a curly bracket pair, then we have a square bracket pair. So in this case, if it matches, so we simply move j backward. Okay, so we don't worry about if like whether we should remove. You can remove, it doesn't matter even if you put, because it will, if there are more open brackets, it will overwrite automatically. Now, if that doesn't happen, if there is no matching, so that means there is a, like, the ordering is not correct. Ordering of closing is not correct. The second point is violated in the valid string conditions. So in this case, we simply return false. Now, if we are successfully parsing the whole string without getting the errors, like not, or without returning false in any of the statements above, so we can simply say that if the j is reached to -1, that means it's empty, the array is empty, that is the structure we used. In that case, what happens is uh, we return true. Okay, we can put a if else statement, but this takes care of it. Okay, we don't need to do anything. Let's run it. Oops. Oh, okay. So I made a mistake over here. I didn't see I typed twice. Never mind. This should work. So, oh, I made several mistakes. So many wrong answers. Why? So let's see, the top of the array is this, and the length is this, that is fine. Int is j minus 1. So increment j and push z whenever we have this character. Then if the closing bracket comes in, we have j equal to -1. And let's say we return if j is empty, j is like pointing to -1, then we have an empty array. So if a closing bracket comes, we return false. Let's say we have j over here, we get the top of the like array. So in this case, we check whether the current character, current character should be the closing one, right? I made a mistake. So this is this should be the closing one, right? So I just messed it up. So this should be an open one, right? See, this is what happens when you don't pay attention. This should work, okay. All right, so this is done. Now, if you want to check this thing, like the time complexity and the space complexity, we can like we don't need to go to the graphics, graphical interface, like the writing on the digital pen tablet. So what we can do is simply if we write TC, so here we are passing the array, the input string once only. So which is the length of the array. So let's where n is the length of the input string. Okay, so this is the linear time complexity, and space complexity, we are using an extra array here. So for that we have the maximum, it can have all the input string can have all the open brackets. So this is even if, like, see here we already taking it to be the length of the string. So we cannot it will always remain n, right? The length of the space complexity in any situation, which is this again the n is the input string length. All right. So this is same, but in stack data structure, it will depending on like so okay, so we can like stop here. We're discussing about this, like this is okay, like no more further discussion is required. Now we can use a data structure like in place of array. All right. So in this case, we have a stack. So we just replace it. So stack. We can use a stack or more like it's recommended to use uh, a deck. So you can name it. So you can use array deck or a linked list. It won't, the time complexity or space complexity won't affect. You might see some differences in the LeetCode submission. So we don't require this character anymore, like the pointer anymore. So we check whether we just simply push. We can use the stack push and pop, and in this. So this is, you can write C, and then we have to check whether this is stack is empty. We can do it like this, and this is the top of the, so top we can just take stack peak. Okay, so this will give you the top without returning the element. In this case, we just simply stack pop. We remove the elements on the top, element on the top, and here we check whether the stack is empty. All right. So again, the time complexity is the same. Like it depends on like the time complexity will remain the same. The space complexity the worst case will be that if all the input the whole input string contains all the opening brackets. So we have to use the whole a stack size of like n. Okay, where n is the length of the input string. All right. So that's both the space and time complexity is clear. Now we can let's see. I'll not submit it. We'll check if it works. Yeah, it works. And okay, I'll submit it again just to make sure everything works fine. Now, one optimization you can do, so don't go for the time complexity. It changes like the time runtime given on the LeetCode. So what we can do is we can use the map to make a little more neat the code to be neater. So what we can do is we can like make a map of the array, the characters, okay, so that it looks a bit. So this won't affect the this space complexity. We can simply map what we have this character and the corresponding closing bracket. Now map what, okay. So it like the logic is same. There is nothing new here. Okay, logic remains the same. So basically, okay, we need to reverse this thing because we'll check for the closing brackets, right? So this is the closing bracket, and we have, yeah. Now this works. Now if so open like this statement remains the same, everything remains the same. Here we can simply do this thing. We can just remove these things. We can remove everything over here. Like we can remove, so we can directly check if the stack is empty, okay, and or we can like for both the cases it will be, and the stack peak. So we'll get the map for it. Map get stack is, so this is equal to stack pop. So we don't require like we simply remove it. If it matches, it will be removed. If it doesn't matches, we don't anyhow return the return it to be this thing false, right? So we don't need to worry about it. So this takes care of like in one go, everything is taken care of. The whole thing. So you can see that like the code is shortened a little bit. It doesn't affect anything else because the map is very it has only 3 entries. Okay, so this is the O of 1. Okay, this won't add anything to the space complexity. The time complexity remains the same because we are passing the whole input stream. So let's see, this should work. Oh, did I? Okay, missed this thing. And let's see if we didn't miss anything over here. Okay. So the current character, actually we have to put the current character over here is C. So we have to get the corresponding bracket and see if it matches with the open bracket on the top of the stack. What did I do again? Oh, extra bracket. Oh, everything is wrong. Let's go through the code again. So it's a closing bracket. It's open bracket you push through a stack, or if you have like empty stack and we have a closing bracket, so you return false. That is fine. Now in this case, map. So you get the character, the corresponding character, and you see whether this is equal to. Okay, we return it when it's not equal, right? Return false when it's not equal. This is the mistake I made. Okay, so we'll submit it, and the type velocity and space complexity theoretically remains the same. The runtime might change over here. See, the runtime changes, so you can have 3 like different runtimes. So using the array, you get better runtime on LeetCode. So this shouldn't affect anything. So thank you for watching. If you have any doubt in the explanation, anything, you can comment in the comment section, and you you can, if you like the video, you can like it, subscribe to the channel. Thank you for watching. Have a great day.